look at this and like that. No, it's
They're like well known for being the most.
the same.
Yeah, the
Okay, guys, any questions about k-nearest neighbors? Okay, there is the last thing that they ask. Is the recommendation algorithm used by something more similar to the way that Pandora determines music to recommend, or the way that Netflix determines movies to recommend? Explain your answer.
Wait, Kobe.
Yeah.
For C, where we use the weighting, we just add the scores for the 3 nearest over 3, and then
Just again, sorry.
do we add?
I put here the weights, 10 and 1, and then as the last argument I put these weights.
And then how do you arrive at your final answer?
Okay, so I look at the weights. What are the 3 lowest distances?
Those starred.
It's 1, 2, and 3. Now I want to know if I will like the wine, the new wine, or not. So I look at 1, I see that I like it. I look at 2, I see that I like it. I look at 3, I see that I don't like it. So based on these 3 neighbors, the probability that I will like it is 2 out of 3, 66%. Okay? Yeah.
I mean, it's just like kind of a rough guess, because what if one of the neighbors is so much closer than the other one? Right?
So it's a good question. You can suggest, and there are a lot of like improvement to k-nearest neighbors in the best algorithm in the world. But this is what it is, right?
Yeah.
You can think about doing other stuff and assigning weights according to the distance and stuff like that. Of course, people do that in a lot of stuff. Probably Netflix don't really do that. They do things that are more complicated, and Pandora don't do that. It's still like something to know and to like build upon if you want something more. So is this more similar to Pandora or to Netflix? Do you remember what Pandora and Netflix are doing? So Netflix, they compare me to other users, and based on that, they decide if I will like the movie or not. What Pandora is doing, they take different songs and compare between different songs using this the k-nearest neighbor. So here, what I did, I compared between different products, between different wines. So this is more similar to Pandora. Okay. I think that's it for KNN, unless anyone has a general question about KNN.
Is that the only formula that you think we need to know? KNN test? Because I think he's used others.
KNN movie.
KNN movie and stuff like that, what, to fill a matrix and something, this type of stuff?
Yeah.
So I feel that this is what he might ask you. If we have more time, we can solve some of the questions that are more of KNN in and KNN in movies and stuff like that. Yeah. And there is also some formula that actually you can make it, if you have a big data set, you can find where the 3 nearest neighbor, just it will give you the 3 nearest neighbor. But I think this is like what you really need to know. Okay. What is the next? Yeah.
So is that KNN movie, if this were similar to Netflix, we would use that?
No, it's not about this. It's not about it. It just helps to do more stuff to fill in different things that we don't know. If we have some data miss and something like that. It's not related. It's that Pandora, just if you do it on users or if you do it on products. This is the difference. What is the next subject we need to do?
Overfitting.
Overfitting. We can do overfitting. Overfitting is not a big subject. Let's do it after skill versus luck.
Oh, yeah.
Let's do skill versus luck. Guys, any questions or things that are not clear? Okay. So skill versus luck. As you know, in any test, in any game, in anything like that, there is some element of skill and some element of luck. So let's say that I'm speaking about statistic exam. Scores in statistic exam. There is part of it that is skill, that you know the formulas, you understand the concepts, you know how to solve questions, and some of it is luck. maybe the professor asked about a specific question that you knew, or maybe you just, I don't know, choose the answer and got lucky, or anything like that. How can I understand in a specific, for example, in the statistics exam, how much of that is skill and how much of that is luck? Any thoughts? Yeah.
You run the data again and again and again.
So what I
until
can
the bug
do, I can do
disappears.
2 consecutive exams for the same people and see if they got the same results or didn't get the same results. Okay? Okay? We actually run a regression of score 2 as a function of score 1. Okay, so let's say that the statistic exam, and this is score 1, and this is score 2. Let's say that the statistic exam is totally skill, totally 100% skill. What do I expect to see as the result? I expect to see this type of line. So someone that got 0 in the score 1 in exam 1 will get 0 in exam 2. Someone that got 50 will get 50, and someone that got 100 will get 100. So what is going to be the slope here? It's going to be a slope of 1. Okay. Specifically, score 2 is going to be just 1 multiplied by score 1 plus 0. The intercept is 0, the constant is 0. On the other hand, let's assume that the statistic exam is totally luck. What do I expect this to look like? I expect to see no relationship. So actually the line that will connect the two will be something like that. So my guess about score 2, about exam 2, if I know score 1, is just an average number. The same number, no matter how much you got in the first exam, I think you will get the same. And intuitively it makes sense. If I'm telling you that the statistic exam is like tossing a coin, and now I'm telling you, hey, I got 80 in the previous exam. The best guess that you can make about my score in the next exam is just the average score. Then it will not be too far. So this will be the average score of the exam. And the equation that we will get is that score 2, the regression will give us, it's 0 multiplied by score 1. I don't give any weight to score 1. Plus, let's say that the average was 50 plus 50. This will be the average. Is these two cases make sense to you? Is it intuitive? Now, usually things will not be perfectly skilled and will not be perfectly luck. It will be some type of a combination. So I will get something like score 2 is 0.6 multiplied by score 1 plus some type of a number, some type of constant. So it will be like something. Now, the important number is this number. Okay? The result of the regression, this is the slope. In Excel, we can just use the slope function to find this number. We will get to that. But this number, we call it the shrinkage coefficient. What it tells you is what is the percentage of skill in the game. So, when I got this 0.6, I know that this game is 60% skill and 40% luck. Now let's see how we make a prediction. So then let's now say that I'm going to do a statistics exam, another exam. And in the previous exam, I got 80. What will be your guess about my score in the next exam? So the guess will be, your estimate will be, you will take the 0.6 multiplied by my previous score, which was 80, plus 0.4 multiplied by the average score, which let's say it's 50. So you put 60% weight on 80, my previous score, and 40% weight on the average score in the exam, which is 50, and this will be your estimation. Now, why do we call it shrinkage coefficient? Because if you think about it, if, for example, the exam is totally luck, people that were very, very high score in exam 1, what will happen to them in exam 2? For a perfectly luck exam? They will decrease. And what with the people that were very bad in the first exam? They will increase. It's not that the people that were bad in exam 1 will be better than the people that were good in exam 1. Just compared to what they did, this guy will increase and this guy will decrease. Okay? Now, in a perfectly luck exam, it will totally be like everyone will go to the average. In an exam that it's like about 0.6, there is some shrinkage. The top scorers, for example, that someone got 100 in the exam, he got 100 because he has some skill, but 40% of that was luck. So we'll shrink, maybe not to 50, we'll shrink to 80, if it's 60% skill. Yeah.
I just can't read that bottom line. It's score 2, the bottom.
Estimate this one?
The bottom line?
This one?
The bottom line right there?
Oh. Score 2, 0.6 multiplied by score 1 plus 40.
Oh, cool.
Plus constant, I just put something. Is the result. What I care about is 0.6. This is the shrinkage coefficient.
Sorry, and the 0.4 is just 1 minus the shrinkage
Exactly.
coefficient?
Exactly. The formula of the guess is C multiplied by score 1 plus 1 minus C multiplied by the average. Because if I think it's totally luck, I think that you will just get the average. Yeah.
If that's the formula, then why is that last formula? Like, shouldn't you have?
This one?
Yeah, like. 'Cause
No,
right now I
this
have a
one.
weight.
This one is not a formula.
Yeah, it's not the
This is the
formula.
result of the regression.
Right, but
When I
then
run a
you have
regression.
So you have a weight of 0.6, but shouldn't you have, like, shouldn't it sum to 1, like, because you have C and 1
No,
minus C?
like this one, if we look in the numbers, in the regression it's not always will be this way. But it's supposed to be 0.4 multiplied by the average.
Oh, okay, that's.
It's
should
not
be
0.4 multiplied by the average, 0.4 multiplied by 50. It's not exactly 4, but it will not always be. I want to show you that it will not always be what you expect. You expect it to be 20. 0.4 multiplied by 50, it will not.
But it is multiplied by the weight of 0.4.
What do you mean?
Like, because the weight should sum to 1, right? Because you have C and 1
Here?
minus C. Yeah.
So here is the result of a regression. There is no weights.
There's no.
I do the weights. When I do estimation, I use the weights.
Mhm.
The regression just give me an equation. Yeah, here it's sum to 1. Could not sum to 1. Could be 1, score 1 plus 0.1. I will still look only on this one. It shouldn't be. It should be this way, but it's not perfect, right? We have data. The data is not perfect. There are some errors. So I only use this number. From the regression, I use this number, C, and then I'm using this formula.
So your slope is C, right?
My slope is
So the shrinkage coefficient is always skill.
is always what?
Skill.
The shrinkage coefficient is always the percentage of skill. This is the minimum.
And the average is the average of all data.
Of what?
And the average is the average of all data that we have.
So probably if they tell me what is the average score, I will just use this number. If they don't tell me, I will take the average of what I have. Yeah. Any other questions? Okay. Let's have a question about this. So let's see what type of question we have.